Okay, we're going to continue factoring higher degree functions in this video. We started with binomials, then trinomials, and now we're going to see what happens when we have polynomials of more than 3 terms. So x cubed plus x squared plus x plus 1. How do we factor this? Well, what we're going to do is a method called grouping, where we have 4 terms here. So we're going to group the first 2 into one term and the second 2 into in another group. And so we're going to treat this almost like 2 separate problems. The first problem is x cubed plus x squared. What can we factor out of that? Well, we can factor an x squared out of that. So we factor an x squared out of x cubed plus x squared, and we'll be left with x plus 1. So this here produces the first 2 terms. And now, what can we factor out of the second group, x plus 1? There's nothing we can factor out of that. So we're just going to leave that as x plus 1. So now you see here that we have x squared being multiplied by x plus 1, and then just x plus 1. We can put a 1 in front of that, so we have 1 being multiplied by x plus 1. And the reason we're going to do that, it's going to make it a little clearer when I rewrite this as this. X plus 1 times x squared plus 1. Now you see where the x plus 1 came from. Where did x squared plus 1 came from? Well, here's the x squared and here's the 1. What we're doing here is we have x squared and 1 both being multiplied by x plus 1 terms. So therefore, that's the same thing as x plus 1 being multiplied by an x squared plus 1 term. And if you were to simplify this back out, you would see that's the case, because we'll end up with the original problem. X times x squared is x cubed. Then we have plus x squared, and a plus 1. So what this shows is that if we have 2 things being multiplied by the same term, we could group them together into one other term. So this is the grouping method that we're going to be using. So same thing here. When we have 4 terms, we're going to just first start by looking at the first 2. What can we factor out of here? Well, we can factor out 2, and we can factor out x squared. So then we'll be left with 3x plus 1. And now what can we factor out of the 9x plus 3? We can just factor out a 3 from there, and we'll again be left with 3x plus 1. So, once again, we have a 2x squared and a 3 being multiplied by a 3x plus 1, which means the 3x plus 1 can multiply by 2x squared plus 3. It's the same thing. Okay, now here we are going to factor out from the first 2 terms 6, and then we can also factor out x squared, and we'll be left with x minus 3. And now here you can see we have 3 minus x, so that means we just have to factor out a negative, so it becomes x minus 3. And so this is going to be x minus 3 times 6x squared minus, you could put a 1 here if it makes it more clear. The coefficient, if you don't see it, remember, is just 1. So this is just going to be 6x squared minus 1 times x minus 3. Now with this one, before we even get started, you notice that we have something that's common in all 4. So if that's the case, we can factor out, in this case, an x squared before we even get started with the problem and grouping it into 2 groups of 2. We're actually going to factor out a negative x squared so that the first term turns positive, because that's going to make it look a little neater. So we're going to factor out negative x squared, and then everything is going to turn positive, and the exponents will decrease by 2. Well, actually not everything turning positive. We're going to flip all of the signs, negative to positive, and vice versa. Okay. And now from here, now we're going to just factor out of, here we have a group of 4 now. We're going to factor out of this group, we can factor out an x squared. And that will leave us with 2x minus 5. And then from this group, we can factor out a 9, which will also leave us with 2x minus 5. So now from here, we still have this negative x squared sitting on the outside. And now look inside this parentheses and see that we can have a group 2x minus 5 multiplying by an x squared and a 9, so that's going to be x squared plus 9. So now once again we have where we could factor out something, in this case an x, right away. But what would happen if we don't do that? Let's just not factor out the x right away. It might even be a little bit neater this way since we won't have anything sitting outside the parentheses. And we'll just start by grouping the terms together. So from the first group, we can factor out 2x cubed and be left with 4x minus 3. And from this second group, we can factor out, we're going to factor out negative because we want the first term in the group to be positive. So we're going to factor out negative, let's see, we factor out of 24 and 32. We can factor out 8 and then an x. And we will again be left with 4x minus 3. So now before we write this as 2x cubed minus 8x times the 4x minus 3, notice we can factor out, since we didn't do it initially, now we're going to have to do it here. We can factor out from the 2x cubed and the negative 8x. That's going to become one term. So to save a step, let's just do it now before we even write it as a one term. We can factor out 2x from that. So factoring out 2x from 2x cubed minus 8x will leave us with x squared minus 4, sorry. Times the 4x minus 3. And now, always check to make sure there isn't one more thing you could factor. Technically, we've done all the factoring we need to do here for higher degree expressions, but notice that there's still a quadratic in here, x squared minus 4, that can be simplified out just a little bit more into x plus 2 times x minus 2. That little factoring can often come into play here. And that will be important to do all of the factoring, including that last step, once we start graphing, and you'll see why. Okay, now we're going to move on to the second half of this video. Okay, so with this one, it might look a little strange because we have all these different exponents now, but if you'll notice, it's really just a pattern, 10, 7, 4, 1, going down by 3. So that makes this problem completely factorable. So we're just going to treat it like a normal factoring by grouping problem. Factor out an x to the 7th from the first two terms, and then factor out a 4x from the last two terms. But what you'll notice is that once again, we can factor one of these two terms. That is it the x squared plus x to the 7th plus 4x? No, there's nothing we can factor out of there except for an x. So that's pretty easy to do. Might as well do that now. X to the 6th plus 4. So we factored out an x from that. But the real thing we can factor here is this x cubed minus 8. That is a difference of 2 cubes, which we looked at in the higher degree binomials video. So this is a cubed minus b cubed, which the formula for that is a minus b. So the a is x and the b is 2, so it's going to be x minus 2, times a squared plus ab plus b squared. So a squared is x squared, ab is 2 times x, and b squared is 2 squared of 4. So there what we actually did was we rewrote this factored by grouping form, and then we factored out an x out of both of the other terms. So we did a lot in one step there. And now we are going to take a look at something that we definitely haven't seen before. And I think you can figure out what that is. We have a lot of terms here. We have 6 of them. So what we're actually going to do here is we're still going to group them into groups of 2, but now we're going to be left with 3 groups of 2. So we will be dealing with these very long polynomials in the future, so we do need to learn how this works. So we're going to factor out negative 2x to the 11th from the first 2. And we're going to factor out 7x to the 7th from the next 2. And you notice we're getting x squared minus 2 for each of them. So if you ever don't get that for one of them, you know you did something wrong. And then we're going to factor out negative 5x cubed. So it might be a good idea to always keep checking as you're writing this term that you're factoring out of everything. Keep checking that it really works as you're doing it. Don't just assume it's going to be x squared minus 2, because that's how you're going to catch errors in the term that you wrote here. If it's incorrect, you'll catch that by checking that this really does multiply back into these 2 terms. So just keep that in mind. Okay, so now we're left with 3 terms that are being multiplied by the x squared minus 2. And you'll notice that we can factor out some x's from them. We can factor out x cubed, in fact, from all of them, as well as a negative sign. We're going to want to do that since the negative is in front of the first one. So we'll factor out the negative, and we'll get, now we're just going to negate everything and reduce all the exponents by 3. And that whole thing is being multiplied by x squared minus 2. And we are not quite done yet, because this is another factorable term here. This is a higher degree trinomial. And since we have coefficient other than 1 in front of the highest term here, we're actually going to factor this using the x method. And these are not perfect squares, so we can't do that little shortcut either. So we're actually going to look at what are the factors of 1 and 2, what are the factors of 1 and 5. This is actually not that hard. And how do we get negative 7 when we multiply across and then add? Well, we just negate both of these, negative 1 and negative 5. So now these multiply to 5, these multiply to 2, and negative 5 plus negative 2 is negative 7. So we still have this negative x cubed on the outside. And now remember that the exponent is reduced by a half when we put it in the factored form. So we're going to have x to the 4th plus or minus constants. So we're going to have 1x to the 4th minus a 1 times 2x to the 4th minus a 5. And don't forget that we also have this x squared minus 2 floating out here. Okay, and now let's take a look at one last problem here. And to make things extra crazy, we're going to throw in 2 variables. as well as some negative exponents, which you can see because we're dividing by higher degree terms. Okay, so first thing we're going to want to do here to make this easier is get rid of negative exponents because they're just going to complicate everything. So the highest negative exponent we have here is x to the negative 3 if we were multiplying. So let's just factor out x to the negative 3 from everything, which means all the x's are going to go up by 3. Since we're factoring out negative 3, we need to cancel that out by putting all the x's up by 3. So we're going to do that. This is x to the negative 1, so we add x, we multiply x cubed by that. We multiply the cube and we just get x squared. The negative 1 went up by 3 to squared. And now it's in the numerator, so it multiplies by the y cubed. And then x to the negative 3 times x cubed will just go away and we'll be left with just a constant there. Okay, so now this looks more manageable. The challenge is that we still have to group these terms into two groups and then factor out x's, y's, and constants from all of them. So just looking at these first two terms, what can we factor out? We'll go one step at a time. First, don't forget the x to the negative 3 in front. Now, what can we factor out from these two? In terms of constants, we can factor out a 3. In terms of x's, we can factor out x to the 4th. And for the y's, we can factor out y to the 6th. It's just the lowest exponent of each. And now we just see what's left. So we're going to be left with, in this term, we're not left with any numbers since we have the 3. We need an x squared to build back the x to the 6th, and then we need a y cubed. And in this term, we already have everything here except that the number is negative 6 instead of 3. So we just need a minus 2 to build back to the negative 6. And now look at this. This is exactly the same as this. So we don't have to factor anything out of this next group. It's already there. So we just add that back in. So all of this factors out to 3x to the 4th, y to the 6th, plus just 1 of that, times this, x squared y cubed minus 2, times x to the negative cubed, or divided by x cubed. And we are done with factoring higher degree functions, or at least learning how to do them. We will be applying this more later. But in the next video, we're going to start with something completely new that you will need to know this in order to do that. But it's kind of interesting. We're actually going to be revisiting long division, but this time with polynomials. So let's see how that works.